Hello and welcome to the Programming in C++ Part 2 series. Welcome back if you've already been here this long. In this video we're going to cover Programming in C++ Chapter 15 exercises which deal with recursion. So please go ahead and smash the like button, leave a comment, and make sure you're subscribed to the channel. When you subscribe to the channel, you get update when new videos are posted. Also, if you're unable to like or comment or subscribe, means you're not logged in. If you have not yet created a YouTube login, please remember it is absolutely free and takes less than a minute. Alright, so let's go into our first exercise of this video, which is going to be Programming in C++ Part 2, Programming Exercise 15-18. And here we're going to, so the sequential search algorithm given in Chapter 8 provided is non-recursive. Write and implement a recursive version of the sequential search algorithm. Your program should prompt the user to search the list for an integer to search for in the list. Use the following, the array of digits that's listed there. If a match is found, output the index where the element was found, basically which position. If the integer is not in the array, output the following message: X is not in the array. The user should be able to run the program more than once by entering Y, or N to end the program. All right, and then task 1, sequential search. Must work. Alright, so let's go ahead to our main. Looks like they provided some for us, and they did. Looks like a mess, so we'll be cleaning it up. So let's start by just pushing this line down 1. And so it's traditional, actually. I don't think we need this constant array, so let's get rid of this. And we have, so our function, for one thing, I hate these comments, drive me crazy. Alright, so we need to change this to, so it's called the rec search, or sequential search. Sequential search function. And then we have our constant integer list, integer length. Let's change this to length. And this one, just integer item. I'm going to get rid of these comments. Easy for me as I go through the numbers. What is this for? This doesn't make any sense. Alright. I'll give it a break. So now let's go up here. Let's bring this up one line. So now we have our integer list array size. So let's make the array size 15 in the array size, and then we'll equal, and we're going to put our array in our brackets. So we'll do 2, 6, 8, just follow the numbers in the instructions, 23, 45, 43, 51, 62, yeah, so I'm just following these right here. Let's go back. 62, and comma and a space to separate them. 83, 78, comma, and let's go down here. 8, let's go 61, 8, 71, 34, 72. Alright, so they got that array complete. Let's take a quick break. We'll be right back after this. Alright, so I'm tempted to just delete this because it's in a way it's not really helping. Yeah, we're going to do that. Don't need this, don't need this. Let's try this, move this out of the way. Alright, let's get our variables back, finish our variables, to finish declaring them. here. Let's go integer item and integer location. Location is going to be the spot in the location in the array. So remember 0, 1, 2, 3, 4, and so on. There we go, char and ch for character. And let's go cout, and now it wants us to continue by going yes or no. I want to add more numbers or do multiple searches. Search the list, and we will go parentheses capital Y slash lowercase y, or capital Y, comma lowercase y, and then slash capital N, comma lowercase n. Then we'll colon there, and semicolon. Cin, and we use the ch variable, and then cout in line. Then we'll do location equals rec sequential search. Did I put dirt? Search. Okay, let's get this. Yep. Did put dirt. All right, got that correct. And okay, where are we? Nah, that ain't gonna work like that. I need to add something else in there. But we'll finish this line because I think I know what I need to do. List 15, comma item. And then, so we're gonna turn this into, I think we gotta turn this into a while statement. So, yeah, so right here we'll go ch is equal to capital I, or lowercase y. Ch is equal to lowercase y. Then we'll do brackets. And we'll do cout. Enter search item. This might be already on there. I'll need to check the code. It is, I'll delete it. And item and cout and live. Alright, and let's throw this up there too because we're going to need this inside the while statement. X. Gonna be on this cout line. Okay, and where is my list not clear? Let's see. Search list 15. List constant integer list. Get back to that. Location. What do we have now here anyway? Enter your number. Search. Yeah, I'll have to end up just getting rid of all that because I'm sick of it. It's in the way. What it is from scratch. It's confusing me. So let's go. We'll leave our return 0 in. We'll get rid of this right here. And we'll get rid of this. Alright, so there we go. This list is so this list. So rec sequential location equals rec sequential search. That list. This shouldn't matter, but let's do it anyway. To finish the statement, then let's move on. So we got if location not equal -1, cout item variable, let's try item should be found at position. And then, yeah, let's do that first. And let's bring it down and continue. Location. Location variable. And then in line. And here we'll do an else. Out and item and do that here, not in the list. In the list and go line. Alright, so take a quick break. We'll be right back after this. Alright, so let's go here, still inside this bracket. Let's go back to our regular indent, and let's go cout, search the lists, and we'll be able to say y n, and then we'll do colon, semicolon, then CIN, character, and cout inline. There we go, and didn't have a return 0, I don't believe. Didn't have my close bracket either. There it is. Return 0, and we'll do the bracket up 1. So there we go. 2. Let's see what we got here. Yep, everything looks good. So let's go on. Let's put it on 4. More space. Let's get this. Copy this function. Put that there. If length is greater than 0, I'll skip brackets for this because we need another if list length minus 1 okay, and this will have to equals item. And then we can return length minus 1. Then let's go else here. And we'll return sequential. Search. Sequential search. It's like, now where did it come up? Rec. Sequential search. And we'll do list, comma, length minus 1, comma, and item. And then we'll put the semicolon there. This for this if we'll do another else, and we'll return, this has to be -1. Alright, so it looks like we got it licked. Let's see what we got here. Alright, let's go to the run, and then we'll show the code. So I'm about to restart this. Alright, we're back up, so let's go ahead and run it. Now it ran that time, so let's see what we get. Search the list. Let's go, yeah. Enter search item 51. When found in position 6. Search again. Let's go 62. This is 7. Search again. Why not? 11. Not in the list. Okay, so we got every. That looks good. Promising. So let's go down here and calculate grade. And while we're doing that, let's look at our code. Alright, so here we go. It's line 1 through 18. As always, go ahead and pause as you need to. And then if you need more time, pause it as I'm going to scroll down. So that's line 19 to 35. Same thing. Pause it if you need to. I'm going to scroll down. That's 36 to 51. And scroll down again. That's the end of the code. And I'll slow roll it one more time for you. Alright, and there she goes. So let's see if we calculated. Yes, we did. We have green and 100. So what we'll do is let's go on to our next exercise, which is Programming in C++ Part 2, Programming Exercise 15-19. So we'll jump right into those directions as soon as we come back right after this. Right. So here in the programming example, converting a number from decimal to binary given in this chapter, you learn how to convert a decimal number into the equivalent binary number. Two more number systems, octal base 8 and hexadecimal base 16, are of interest to computer scientists. In fact, in C++, you can instruct the computer to store a number in octal or hexadecimal. Appendix C describes these number systems. Digits in the octal number system are 0, 1, 2, 3, 4, 5, 6, and 7. The digits in the hexadecimal number system are 0 through 9 and A through E, or A through F. So A in hexadecimal is 10 in decimal, B in hexadecimal is 11 in decimal, and so on. The algorithm to convert a positive decimal number into an equivalent number in octal or hexadecimal is the same as discussed for binary numbers. Here we divide the decimal number by 8 for octal and by 16 for hexadecimal. Suppose A, B represents the number A to the base B. For example, 75 over 10 means 75 to the base 10, that is decimal, and 8316 means 83 to the base 16, that is hexadecimal. Then 753.10 equals 1361.8, and 753.10 equals 2F116. Write a program that uses a recursive function to convert a number in decimal to base 8 or base 16. Your program should prompt the user for an integer and then for either 8 for base 8 conversion or 16 for base 16 conversion, and output the conversion on the console. Task 1, conversions. So let's go to it. Right, so let's go. We don't need anything there. What we do need to add our function, which will be void decimal to new base, DEC to new base, and then we'll use integer number and integer base. And a semicolon this function up top. Then let's go here and enter, and let's go integer dec num and integer base cout, enter a non-negative integer, and cn, use the variable dec num, and cout and line. Right. So let's go next to our while statement. Let's number is less than 0. And let's go see out. You must enter a non-negative number. Integer. And let's go inline. Scout. Enter a non-negative integer. And let's do it right there. See it again. Take the number. See out. Inline. Okay, and that's our brackets. So let's go outside of this while, and then we'll go see out. Oops. And enter the base. Parentheses 8 or 16. And CIN, a base variable, cout, inline. Okay. And then let's do a while out here. Let's say base not equal to 8. Or and base equal to 16. And there it is. See out. Enter the base 8 or 16, and we'll go inline, and we'll go see out, enter the base, and C in base. Alright, so let's take a quick break. We'll be right back after this. Alright, so let's come down from our while again. And let's go to intent. Let's go see out. Use our variable decimal num. And to the base. Our variable base, and then let's see, let's go equal space, and I think that's all we need for there, and then oops, let's go back to the decimal to new base. Base, and let's say decimal number and base, and semicolon, and then cout inline. Then let's go return 0. All right, so let's go grab our function, copy that from up here. Okay, so there we go. Decimal to new base, fully decimal to new days. Let's go down to our brackets. Then let's go if num is greater than 0. And use our brackets again. Dest new base. And let's go num divided by base. And then also base. Let's get that. And let's go if num factor of base is less than 10. Out that number. Num base. And let's go else. And we need our static cast. Cout. Static. And we're going to use char this time. And we'll do 55 plus percentage base. That should get us there. Right. So let's go ahead and run this. See if we got what we need. Alright, so I gotta restart it again and run it again. We'll do that. Alright, we're back up, so let's run this. Come on, run it again. So make sure this is. Well, let me run it. Alright, so we're gonna try this one more time. Wouldn't let me run it again. Let's try one more time. Alright, so we gotta restart it again. Let's try to run it again, and this time it's running. Okay, it took 3 times to restart it. Okay, enter a non-negative integer for base 16. For base 16 is 4. That's too easy. Let's run it again. Let's try 391, 16, 187. All right, so there we go. Let's go ahead and calculate that up and check our code. So calculate, and let's go to our main. Alright, so I'll show you the code. Here you go, line 1 through 18. As always, go ahead and pause if you need to, as we're going to scroll down. And then there's line 19 to 34. Same thing, pause if you need more time. We're going to scroll down. And 35 is empty, so we're going to 36 to 52, almost at the end. And pause if you need to, and we'll go boom, 55. Alright, so let's go from the top. I'll scroll down one more time, slowly, so you can capture it. Alright, so that's it for programming exercise, or programming in C++ part 2, program exercise 15-19. So we'll go on to our last video of chapter 15 right after this. Alright, so now we're on programming in C++ part 2, program exercise 15-20. This is the last exercise for chapter 20, or sorry, chapter 15. So let's go and see what we got here. So the function square root or sqrt from the header file cmath can be used to find the square root of a non-negative real number using network method, Newton's method. You can also write an algorithm to find the square root of a non-negative real number within a given tolerance as follows. Suppose x is a non-negative real number, a is the appropriate square root of x, and epsilon is the tolerance. Start with a equals x. If a squared minus x less than or equal to epsilon, Then a is the square root of x within tolerance. Otherwise, replace a with a square plus x divided by 2a and repeat step 1, where a square minus x denotes the absolute of a squared minus x. Write a recursive function to implement the algorithm to find the square root of a non-negative real number. Also write a program to test your function. Your program should prompt the user for a number and output the result to the console. The good news is this is already written inside the function that we're going to use, and along with the CMath, we don't need to write that up from scratch. So task 01, square root numbers, so long as we can square them. So let's dig in and see what we got popping. Alright, so first thing offhand, you know we need to add our CMath include statement. So let's copy this part, and actually let's do this, yeah, because we also would need to do IO manip as well. Alright, and so we add our IO manip, our CMath and IO manip. Now let's go ahead to our function, and it's going to be a double this time, and we'll call it square root, as it already is named. Then we go double num, double a, and double EPISOLN. Let's call it the whole thing. Porcelain, and then we'll do semicolon. Alright, let's jump down here and get our main function ready to get. Now let's go clear our double, clear our variables, call it number, and we also double, and this will equal, actually no, double, see, let's spell it the same as I did there, and I'm just going to equal, so we're going to do 0.001, as far as it can go. And let's do our set our precision for everything else, and we'll do it a little different this time. Show point and line, and let's go see out set precision, and we'll make it 2. Out, enter a positive number, and CIN, we'll use the variable number, and then cout, and line, and cout. Square root of, and with a space there. Getting late, starting to make mistakes. Square root of, then use the variable number again, and just go use our equal, space, equal space, and let's come down to the next line. Say square root, and we'll go square root, where's number, yeah, we got number, because number times number is a square root, and then we use our epsilon. Semicolon. Let's go here and go cout and line. Let's bring up our return 0, and that's it for that section. Let's take a quick break. We'll be right back after this. Alright, let's go back up and get our function and copy that. you want to type it up, you can, but I just do this. And there we go. Let's go brackets down here. And let's go if num equals 0. And I'm going to return 0. Else if, see, we're going to use the fabs, and then we'll use, like they said, another bracket, or another parentheses, a times a minus num, and this needs to be less than epsilon. Is. There we go. So then we just return a, and then else return square roots. And we got num, comma, plus num divided by, let's see, 2 times a, and then let's go, we gotta add our epsilon. N. I spelled this wrong up here. O-L-N. I-O-L-N. Fix it everywhere I go. O-L-N. Semicolon there at least. And I go up top, put in my function right. S-I-O-L-N. Epsilon. See, that's crazy. No, let's do it like this. Find out. Where's it at? Alright, where? So, epsilon. I just spelled it wrong. Epsilon. Epsilon. Like this. Here's a little trick too, which you can do. That's correct there. Epsilon. Gotta do it everywhere. Epsilon. Epsilon. Epsilon, 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 and epsilon. Alright, so A, just return A. Okay, get that straight. Alright, looks like we got a in the mix. So let's go ahead and try to run it. Leave that on there right there. Alright, let me run it. So let's see what we're going to get. Enter deposit number 17. squared. So let's go ahead and calculate, and I'll show you the code after much corrections. So there we go. Make sure you got add your CMath and your IO manip. And that's line 1 through 18. Pause if you need more time with those. Scroll it down to line 19 to 35. And pause if you need more time. We're scrolling down to the end. Alright, so I'll slow roll it one more time for you. And that is it for chapter 15. We've just finished chapter 15, exercise 20. So thanks for joining. Please make sure you leave us a comment, and also make sure, most importantly, that you're subscribed to the channel. So take care, have a wonderful day, and I hope to see you on the next one.